Hello, everyone. This is Uday, and the project that I've done is using natural language processing in the context of poetry. Natural language processing, as we know, has evolved quite a bit over time. The initial stages of natural language processing were very rule-based approach to language understanding. And at the moment, we have things such as ChatGPT, which can generate text in a human way. It's also used widely in the context of understanding literature. And this project aims at showing some applications in this regard. The project is two-folded. The first part is using word embeddings built from a Word2Vec algorithm. And the second part of the project is using the word embeddings that are built from Word2Vec model and building neural networks models and comparing them with a standard embedding layer practice that is often done. The data for this project is extracted from two sources. One is Hugging Face and one is Kaggle. The data set from Hugging Face has around 573 rows of data, and they're labeled based on the era the poems were written. The label being whether it's written during the Renaissance age or the modern age. But this data is not sufficiently large enough to build models. So there was a need for some data enrichment. This is where the second data set from Kaggle is used. It has about 15,000 poems, but they're not labeled on if the poems were from the Renaissance or the modern age, but they do have information on the poets. And based on the poets' time period, these poems can be mapped to Renaissance or modern age. And through this process, the data is now about 4,000 rows of labeled data, and there is still 15,000 of unlabeled data that can be used for word embeddings because word embeddings do not require a label. The pre-processing step is relatively simple in this case. There are only three key things in pre-processing. One is converting everything into lowercase, removing punctuations and everything, and keeping every token to be just a word. The second step of the pre-processing is to do stemming so that every word is in its root form. For instance, loudest would be converted back to loud. The third and final step is encoding within a vocabulary. Because this is a data set that has around 15,000 poems, the vocabulary is around 100K words, and that is not easy to encode in a machine learning model or a neural networks model. It is computationally expensive. And the other reason for creating this stack called unknown is when the model is deployed on a test data set, there is a chance that some of these words are not within the vocabulary on which these data sets are trained upon. So only top 15,000 recurring words are kept as the vocabulary, and every other word that is outside this is just given an unknown tag. And this is what the text looks like after pre-processing. In every text-based data science tool, it is worthwhile to create word clouds just to have an idea of the distribution of words within a given text. And this is what the word clouds look for Renaissance and modern poetry. Next, the next step of the project is to build word embeddings. In a standard machine learning approach for text classification, we often encode the documents in using count vectorizer or TF-IDF vectorizer, in which each document, in this case, each poem, is represented as a single vector, where each element in a vector represents the frequency of a given word. However, word embeddings differ in a way that the documents are not encoded as a single array, but each word is encoded as a single array. And the document is essentially a stack of these arrays. So if each word is encoded by a 32 sized vector, and if a document has 10 words in it, then the document is represented as a 10 by 32 matrix rather than a vocabulary size. The idea behind word embeddings is that if two words occur in a given context, then the vectors of these words would have a higher cosine similarity as opposed to words outside a context, which would have a lower relative cosine similarity. In the most common practice to build word embeddings is using Word2Vec algorithm. The way Word2Vec algorithm works is it defines what a context is for a word. In case of an example like this for the word Arabian, if we take the context width to be 2, then these two words on the left and the two words on the right would be considered as positive context words, and the words outside this boundary would be considered a negative context words. The way Word2Vec is implemented is that it initializes random vectors for target and context words. Both are of the same size. In both target and context word spaces, each word is represented by a vector of a certain size. And for each positive sample within a context, we take some negative samples outside the context. And it is a good practice to take these negative samples based on the probability distribution of the text. And once we get, for example, for each positive instance, in this case, let's say Arabian and Soul is a positive context, and Arabian is the target word, we take 4 other negative samples outside the boundary, and we have 5 dot products that we can calculate, and we then do a softmax over the 5 calculated dot products. And this is then the loss value is calculated using a categorical cross entropy loss, and then we backpropagate and update both the target word embeddings and context word embeddings. In a way, it's a semi-supervised learning model where we don't have an external label, but we are creating labels within the data, and we are reducing this whole process to just a classification model with a loss function. And once we run some epochs and we reduce the loss by to an extent, then the target word embeddings that are generated will be now considered as word embeddings. And these word embeddings can be analyzed using a lot of unsupervised techniques. One unsupervised technique could be just a simple clustering. In this project, hierarchical clustering is done, but because we have a vocabulary size of 15,000, it is impossible to visualize all these word embeddings. And the other way of visualizing these word embeddings is using a TensorBoard. TensorBoard is an API by TensorFlow, where you can pass the word embedding arrays that we've generated and metadata, and it reduces the dimensionality of these embeddings to 2 or 3, and using several dimensionality reductions like PCA or TSNE, and it projects them onto this 3D space. And there are multiple options to visualize these word embeddings. We can just pick a word, and it would give the words that are closest to it, and you can drag and check how many neighbors you would want to visualize in this. It's a really cool interface where you can play with the word embeddings that are generated. The next thing that is done in this project is doing a comparative study of neural networks in the case of classification. because the focus is on the Word2Vec embeddings that are generated, the project compares the models that are built around these Word2Vec embeddings and a more standard approach, which is building an embedding layer within a neural network. So before passing through either of these models, each text is padded and encoded with the index of the word in the vocabulary, so that every text or every poet or every poem or every document in this case is of the same size. So having spoken about Word2Vec embeddings, the way word embedding layer within a neural network model, either just an ANN or RNN layer works, is that instead of taking each embedded layer, we pass in a one-hot encoded vector of words. For instance, if a sentence that we are passing as input has n words in it, and we have defined a vocabulary size of v, then we pass in an n by v one-hot encoded matrix. And there is a randomly initialized embedding layer, which is of the size v by n, where n is the size of each word embedding that we want to encode these words in. And then, so just multiplying this would give n by n matrix, where each row is a word and every row is essentially the embedded form of the word within the text. And then once we get this two-dimensional matrix, it can be flattened and sent through an ANN. It can be passed through a CNN, or we can do RNN. So there are multiple options this goes through. The difference with Word2Vec, using Word2Vec embeddings, is that we don't have to get this embedding layer in between, because we already have the output for this, because the Word2Vec embeddings are generated and each word is already encoded with a vector. The results show that using an embedding layer works better than Word2Vec layer, and this is reasonable because the Word2Vec, the parameters in the embedding layer are constantly updated with every epoch in the classification. So the embeddings are adjusted to perform better with classification rather than just contextual embeddings. So it is no surprise that it works better, but it also has a higher dimensionality and it has more number of parameters as opposed to a network with Word2Vec embeddings. So it's a call to make on which model to use based on the resources that are available. For instance, maybe if it's just a one-off model where you want to classify text into a class or any sort of such model, it is better to just use the embedding layer instead of generating Word2Vec embeddings. But if the task is more generic and there is a series of NLP tasks that need to be done within a domain of text, and instead of generating a word embedding layer every single time, it is better to build a Word2Vec model and get these word embeddings within the domain knowledge that can be used for multiple projects at a time. This saves a lot of time. Yeah, so those are the results that are obtained from Word2Vec embeddings and classification models. The output of the classification model, which gives the class which the model is predicting whether a poem is written, these results can be kind of grouped by and analyzed for different purposes. For instance, we can calculate a poet's poems, the probability of a poet's poem being classified as Renaissance or modern based on individual class which the poet's poem went into. And this would give us some results that can be analyzed to kind of see if there is any significant changes in writing patterns that could lead to this. And this is something maybe somebody who's really interested in poetry can look it up to. But yeah, thank you for watching. I hope you learned something out of it, and good luck.